this video is just for us to get familiar with the whole microcontroller thing. That is, how do we work with it? Okay, what are we going to do with it? Of course, we can do multiple different projects with it, but how do we work with it? How do you work with a microcontroller for a beginner? Okay, so since the aim of this video is to get familiar with it, then what we are going to do is just a very simple project. The project is going to be very, very simple so that we can focus on getting familiar with working with Arduino or working with a microcontroller, in this case, Arduino. So let's just have, this guy is still inside the pack. So this is our Arduino. Okay, so our Arduino here. So yeah, that's it. Arduino Uno. Okay. So yeah, have it here. So since what just blink LED is light emitting diode. So now, like I said in a previous video, that in each project I will explain each component. So I will explain the Arduino, then I will explain, since this project is to blink LED, that means we also need what? LED, light emitting diode. Look at them. LED, light emitting diode. Okay, so we need that. And then what else do we need? Bear in mind resistors. I'll tell you why we need resistors. Okay, one resistor will do. I'll tell you why we need it. And then of course we need this cable. I'll connect it to my laptop. Okay, and this will serve as power. That's to power the microcontroller. Okay, to power the microcontroller. All right, so that's all we need. That's all we need. These are all the components we need. So the rest can see them later. But just since I will connect two components, okay, since I will connect two components, I will just have single holes here. If you look at it, you see holes, single holes, okay, pins. So what I will do, I'll make use of a breadboard. I will tell you why I'm using a breadboard when we start the project. So right now, I'm just talking about the components we need. So we need a microcontroller, we need a breadboard, we need an LED, we need a resistor, of course we need this cable, okay, to power the Arduino, and also load the program inside it. Load the program, what do I mean? I'll tell you. Then, of course, wires, okay, to transfer, oh boy, the menu. We need wires to transfer what? Electrons, electrical signals. Let me just say a few things about the components we are going to make use of. So the LED, of course, which is light emitting diode. Okay, I think I should take this off here. Light emitting diode. Now it's diode, of course, like the name sounds, diode. Diode are electronic components that allow current flow in one direction. If you observe, you see that one leg is longer than the other. Okay, one leg is longer than the other. So the thing is the longer leg is a positive leg, the shorter leg is a negative leg. That means current flows from one side to the other, from the positive to the negative. So if you connect, I have this digital multimeter here. So let's just do this quickly. Okay, while doing the connection, let me say this, that it allows current flow in one direction. Okay, now when current passes through a diode, it lights up. When current passes through a light emitting diode, that's the right way to say it. When current passes through a light emitting diode, it lights up. That's why it's light emitting diode. So observe, longer leg this way, shorter leg this way. So connect it like that. I hope that's clear. All right, hope that's clear. Okay, so what I'm going to do right now is I hope you guys can, I think I'll turn off the lights so you see this. So I'll just set the multimeter to if you observe diode, you can see that. Okay, diode, that's a symbol for diode, that thing that looks like pew, pew, pew. Okay, that dot there. Now, so I'll put the positive probe at the positive end, this side, and then the negative at this other side, so current can flow through and it will light up. So and let me turn off this light so that, okay, so when you do this you should see something. All right, can we see that? Okay, yeah, I believe that's clear. Okay, so we can see that. So this is the nature of this component. Once current flows through it, it lights up. So it can act as indicator for us to show that the instruction we've written to turn it on is actually working. So we are not just going to turn it on in this project. We are going to blink it, meaning on off, on off, on off, on off. Okay, so that's the diode. Then bear in mind that the amount of current that goes through any electronic component, okay, if you think of it, it has to be controlled. If the current going through that component is more than what that component can take, that component will be damaged. Okay, so to reduce the amount of current flowing, we use what? Resistor. Let me say it this way: to resist the amount of current that flows through a component, we use what? A resistor. So I just pin down the resistor here so that we can touch with our probes and see the value. Note, resistor doesn't have negative or positive. It just resists the flow of electrons of current. Okay, so of course resistance is in ohms, so I put it here. Now the resistor have different values, and you can see it's okay, you can see that, yeah. So you can see different lines on it. Those lines, those colors, they are actually code telling you the value of the resistor. All right, but at least we know it's
0.2 something kilo ohms, which is the same thing as 200 and something ohms.
So for the breadboard, is connected internally. If you look at this, just know that every part from like this is connected vertically downward, connected, but not horizontally. Okay, vertically downward, connected like this. Same to this part, vertically downward. This space here shows that here and here, these two parts are not connected. Okay, then this and this they are not connected. This and this are not connected. Now you look at this part. This is connected horizontally, but like this not connected, but like this connected internally. The same to this guy. Usually this part is used for positive. Hope that's clear. Okay, this part is used for the positive, and this part is used for negative. If you use any side, it will still work. Okay, but just for convention. Okay, so this is the other thing we need is this guy. Okay, this cable. This is USB cable type A. Okay, better. USB cable type A and type B. This is the type A. Look at it. Okay, this is the type A, and this side is the what? Type B. So this cable transfers power and data. So this side is connected to your laptop, the type A connected to laptop. Type B, this part is connected to the Arduino. So it sends power, it turns on, powers the Arduino, and then it sends data, your program, your instruction, all those things to the Arduino. This whole thing is the Arduino. Now, that's for the code, okay? So let's go into the Arduino. Let's talk about this guy. Now, this whole thing is the Arduino. This single thing here is the microcontroller. Are we together now? Let me turn it this way. Yeah, I think it's clear this way. Okay, so can we see what's written here? At mail. Okay, that's what's written there, at mail. But this thing you see here, this is the microcontroller. A microcontroller has CPU core which means it has something that processes information, processes data. It has CPU core, it has RAM, it has input and output interface inside this guy, all integrated in one chip. Okay, but for us to interact with this chip, we need all these external guys, USB ports, power ports, like to power the Arduino. This guy, we can power the Arduino and send it out through this part, but here we can also power the Arduino from this part. Okay, then you see all these ports, digital, all these are analog ports, but ways we can interact with what? The microcontroller. All these other guys are things that will help us interact with the microcontroller. These black guys, the microcontroller. This whole thing is the Arduino. Clear? Now, what we are concerned with in this particular project, what we'll be concerned with is these guys, these pins right here, and this one. But we've talked about this one already. So these pins right here. These pins here are digital pins. If you look at it, you should see something there. Yeah, digital PWM. PWM is pulse width modulation. So digital, however, it behaves like analog, pulse width, pulse on, off, but behaves like analog. So don't worry about that one for now, but just know that these are digital pins, on or off, 1 or 0. But whether this pin should behave as input, that is to receive data into the microcontroller, or it should serve as output to give out something from the microcontroller, that will be determined in our program, which we'll talk about later. Then these other pins here are also they are input only. If you look at it, you see there analog in. So you see A0, A1, A like that. Okay, so these are for continuous signal, not on and off digital. Okay, these are for continuous signal, things like sensors. Okay, now for this other set of pins, they are what? Power. Look at it there, you see power. Okay, so 5 volts RES, 3.3 volts, 5 volts again, ground. When we make use of them, you see what we mean. But this is just the simple overview of the Arduino. Okay, it's just the back. I didn't make mention of the TX and the RX. TX transfer and transmitter, and RX receiver, transmit and receive. When we get to project concerning that, we'll deal with that. So let me make this short as possible. Then this button is for reset. Okay, when your program is running, if you press this, it will reset. Okay, like back to the start again. All right. Okay, so let the connection begin. Now, I'm using breadboard. Breadboard is just extending things from the Arduino. That's just it. I can even do without the breadboard. Connect this one, the LED. This one will go to one of the pins. If I connect this one to the 5 volts pin and then connect this other side to ground, if I connect this one to 5 volts of the Arduino and then this one to ground of the Arduino, once I power the Arduino, this guy will go on. This guy will turn on at once. Okay, because it's receiving the 5 volts and it's connected to ground, so currents will flow. That's electricity. Okay, so it will turn on. But to control it, we need to connect the live to the digital pin. So now we will be the ones to determine if the pin will serve as output for us or input, and when that output will happen, we'll be the ones to determine it. If we connect the live, which is the positive, to this pin, that's what we are going to do. So remember we said we are going to add a resistor so that it will limit the amount of current flowing through it, so you will not damage this guy. So since we want to connect this guy to this pin, but in between we want to connect a resistor, so just connect. Let me use something long. Just connect. Let's use pin 13, or let me use pin 12, pin 12. So just connect. Can we see what's going on? So I just connect this one now. I think that's pin 12. That looks like 13. Yo, that's 13. Go to 12. Well, it doesn't mean I for one there, but I'll tell you why. Pin 13 has a built-in LED already. Okay, so you can see connected there, no problem. So this one now is supposed to be connected to where? This guy, right? The positive. So put it like this. Just put it somewhere where you can. Just put it here. Okay, so let me show you what I'm doing. So you do what okay, enter. Okay, we're good. So it's there now. So now I connect this one to the live, which is this part. But instead of doing that, I need to put my resistor first. Okay, so connect my resistor. So this is the resistor now. Connect it to the live part. Okay, connect this one there, and then this guy, just extend it further. So now I can put this one here. Hope you can see what's going on. Now I can put this one here. Just going now. Just okay. So we have the live connected. Then for the ground, we can connect this. For the ground, that's GNZ. Okay, so I just connected ground. So and for me, I'm sending it to this pin, to this part. You see this negative here? Guys, I think I need a better camera and lighting and light system. So I just connect this one here, meaning by the time I connect from this part, you see this part now, I connect from this part to the Arduino negative, which is this other leg. Is that not too close? Hope you guys can see what's going on. You now have connected here to positive now, this side to positive. So, and I connected this other leg. I plug the LED inside. This side is negative and this side is positive. So I'll plug this one here. Sorry, this side is positive, this side is negative. So I'll plug this guy here. Good. So guys, our system is ready. Our system is ready. So what's left now is the instruction, the program to power this thing. So I just need to connect this guy here. Okay, so connect it to my laptop and it will be powered. This whole system will be powered. Then the instruction on how this guy should behave, this one should behave, that one will be in the program. So I'll do that right now.
Okay, this is my desktop background, and then you just come here and search for Arduino IDE. Now, if you don't have it installed, you can just go and type online Arduino IDE for, if yours is Windows, for Windows, just like that, and then install it. Just click follow and just install like that. Now, there's a video. What did I type? Yeah, Arduino. Yeah. So I'll drop links to a video where you can follow up with the installation process in case maybe you just want to follow some, like a guide. I'll drop a link to a YouTube video you can follow to do the installation. So just click this and to open up. I already have it open here because it takes time. It takes time for it to load. So I've opened it already. So I just show you how to search for it. Just type Arduino here. All right, now once you open your Arduino IDE, this is what you see for the first time. Of course, you can go to File and then go to File and New Sketch. Then you save. Let me make this a little bit bigger. I think this is big enough, bold enough. Yeah. So I just press Ctrl and plus sign to make it bigger. Ctrl and minus sign will make it smaller. Now, when you open your Arduino IDE, this is how it looks like for the first time. These are the two functions that you really need for a start. A setup function and then a loop function. They do not return any value, so that's why it's written void setup, void loop. Now you have to understand C or C++ in order to work with this. So I will drop link to a video on that also from Neso Academy. But if you follow up with this video step by step, at least you get familiar with the process, with what's going on. So the okay, I guess you're following so far. Now, for your Arduino IDE, once you install it for the first time, I've said you see this, but the background is not dark, it's white. Okay, white background. Yeah, that's it. But I just customize mine to look like this. I like it this way. Okay. So obviously we can see if you put double slash before you write anything, those things are comments. Comments are readable statements. They are statements for you, the programmer, telling you what you have there, like talking to you. But those, what you've written there, comments are not executed by the machine. Okay, they are information, or they are things written down for the programmer or other programmers, or for human being to see and understand, but they are not executed by the machine. So once you run, these things will not be compiled. They will not be interpreted or compiled. Okay, the machine doesn't have anything to do. The machine doesn't have anything to do with this, guys. Okay, if you observe, if I remove you see the color, we now have a different color. Okay, so all right, now we put our setup code here to run once. Setup code here to run once, what do we mean? If you observe, you see this curly brace, right? Curly brace. It means everything inside this curly brace is under the setup what? Function. A function is a block of reusable code. Okay, reusable instruction. So what we'll do here, any instruction we write here is to run just once. So this setup, just like the name, is where we set up the Arduino, or set up the way we connected the way we did the physical connection. We'll do that in here. Now, for pin 12, that's where we connected the LED to, right? So instead of using 12, writing 12, 12, 12 inside our program, let's just make it a little bit readable. Say LED. Okay, this thing means anywhere you see the rest part of our program, when we write LED, we are saying anything that happened to LED in the rest part of our program should happen to whatever that is plugged in pin 12. Use semicolon to end your statement, to end your instruction in programming, in C programming. Okay, C++ or C programming, or C. Now, this thing here, what is the data type of this? This is an integer, right? 12 is an integer. So you say what? Int. Are we following? Int. So this is the data type. This is the type of data. This type of data is an integer. So you say int. Then you now put LED. Okay? Now, this is a variable. LED is a variable. Now, it must not be LED, oh, please. It can be anything. It can be LD, it can be A, it can be X, it can be anything. But just use something that looks like just use a variable name. Just use something that looks like what you plug to pin 12. Are we getting the point? Use something that looks like what you plug to that particular pin, what you connect to that particular pin. Now, instead of this thing, what we've just done here is variable initialization, declaration and what? Initialization. If I just say int LED, I have declared the variable. I have said LED is a variable, and the kind of data that will be saved under this name or in this name is what? An integer. This is variable declaration. If I now assign a value to it, I have initialized it. It's variable initialization. Note that this LED is just, this variable are locations, representing location in memory. Okay, so this location in memory is what? To hold integers. And what's it holding now? 12. That's pin 12. Okay, so instead of me to initialize this variable here, I will do that outside the setup function, making it a global variable. Listen carefully. Please watch that. I will advise you watch Neso Academy on C programming, so you understand what I'm talking about here deeper. Now, I just said something. I just said global variable. Bear in mind that if I have this thing inside here, inside here, it's a local variable, meaning it's just existing inside the setup function. If I write anything inside the other function and I include the LED, this LED is not recognized inside the loop function, but it's recognized inside the setup function. So it's a local variable to set up. But if I want it to be recognized everywhere, I need to declare and initialize it outside. Declare or initialize it outside a function. Declare it where every other function have access to it. So this is what? It's not a global what? Variable. Are we together? Good. So we have that idea. Okay. So now we can just say this is what variable, or okay, variable. Okay, this is a variable in the program. Now again, this thing just help us to understand what's going on in these parts. This backward slash double slash means that when we are running this program or when we are compiling, the machine will not mind this thing we have written variable. Okay, so note that we have syntax in English. That means rules to write English language. There are also rules to write in this programming. So we are following that rule, and that rule, you don't use full stop, you use semicolon. Okay, so if you put comment this thing here, it means these guys now they don't need to abide by that rule. You can put your full stop, no problem now, but just that the machine will not execute this thing. All right, so for our setup, we said we have LED, right? So should this LED work as output pin or input pin? Should it work as output or input? You know that we want to display, we want the LED to light up, so we'll plug it in pin 12. Now, since we want it to light up, that means we are sending signal to pin 12. It will now give output for us. That means this should be what? Output. Okay, it should be output. Now, there is a keyword used in Arduino to do this. It's actually saying what? Pin. This is a pin, right? LED is a pin now. Look at it, pin 12. It's a pin. So what should be the mode of this pin? So you say pin mode. Pin mode. The pin mode for LED should be what? Output. Are we following? You see the color change. Okay, telling you that this is a keyword or kind of function or something like that. Okay. So now we can close this here. We can just say close setup. Okay. So this thing will run once, meaning once you turn on the Arduino, it will assign pin what? LED, which is pin 12, to act as what? Output. This happens once. So it doesn't need to assign it to output again and again. No, just assign it to output pin once and it will serve as output pin throughout the program. Okay. Now, put for the void loop, put your main code here to run repeatedly. Woo! We've said a lot in this video, boy. Now, hopefully in our next video, we will not say a lot of things because at least we've explained, we've done a lot of explanation. In the next video, I'll just write the code straight. Hopefully, no many talk and things. All right, so put your main code here to run repeatedly. So we said we want this thing. We want to power the LED AB. That means we should send current to what? LED. LED should be what? Remember, it's in digital pin, and digital they are what? On or off, 1 or 0, which is also represented as what? High or what? High or what? Low. High means 1 or high means on. Low means 0 or low means off. So we want to on it, right? We want it to turn on. Then we want it to do what? Turn what? Off. Then this thing will not get to do what? It's not repeat. So when the loop starts, the LED will turn on, which is high. Then it's not turn off. Now, this is a digital pin, right? It's a digital pin. And we are sending signal to the digital pin. So you say what? Digital. So since we are sending signal to it, we say it's what? Right. If we are receiving signal from it, which is acting as input, we say what? Read. Digital read. But now we are sending signal to it, so we say what? Digital write. Similarly, this one is what? Digital right, okay, and then low. Now if you run this program like this, you will, to spot the difference, it will like on off. It will wait for how many seconds? So let's determine that. So you say delay. It should delay for how many seconds? Let me say 500. This is not seconds, so this is milliseconds. So this is what? 0.5 second or 500 millisecond. You can say, if you want to say 1 second, meaning 1000 millisecond, which is the same as 1000 seconds. So let's just wait for, well, not too much, I beg, 500 millisecond. Okay, can actually just copy this and bring it down. Okay, so now if we run this program now, it will set the pin mode to output, and then what? Digital write, meaning the LED will turn on and stay on for 0.5 seconds, which is 500 milliseconds. Then it will go off. It will go off. Then it will stay off for what? 0.5 seconds, which is 500 milliseconds. Then it will repeat again. Go on. Wait for this. Go off. Wait for this. Repeat again continuously as long as there is power. So close. I don't need to write this thing. Close loop. Okay, so we're done. So it's now time for me to connect and run. So you see. All right. Let me go just add this beautiful parts. This blinking and LED. And we have it connected now. All we've done is just plug this guy to the to my laptop, and you can see it's powered. This LED here shows that it is powered. Now there's an LED here that shows that this thing is there's an LED here. It is the internal LED of the Arduino, okay, and it's usually pin 13. So let's compile this our code. So if you click here, it's to verify, that's to check if there's any error or anything like that. So it's actually compiling the sketch, which we can just click this upload, and it will compile and upload directly to the Arduino. Oh, but there's some error here. Okay, this thing should be delay, not delay. Delay, not delay. This guy too. Okay, so let's do this now. All right, another error. Why? Delay. Conversion error. Delay was not declared in the scope. What are you talking about? What are you talking about? Okay, I didn't save this thing. So let's compile. Alright, so that's good. Now we can upload this code to the Arduino now. So once you click here, that will be uploaded to the, of course, the whole system, microcontroller guy there. So just wait for some seconds, and then we should see it blinking. Okay, that's blink. Oh, nice, it's working. So you see the art flash there shows that the code has been loaded into the Arduino. So you can see it's blinking as expected. Now if I remove this thing from pin 12, oh guys, if you observe, do you observe this guy turning on like it's not sure whether it should be on or off? So this guy is the built-in LED. Let's correct this quickly. Now if you look at our code, we did not address it. We've not done anything concerning it. So each state, whether it should be on or it should be off, is not defined. So that's why you see, if I even shake this thing somehow, I think it's supposed to blink. Okay, so what we're going to do now is to address it, is to talk to it. So we say pin mode for what? LED built in. This is the keyword for it, LED built in. We are going to say, of course, output, right? Output pin, because it's giving output signal, and we are going to say digital write for the what? Built for LED built in. Set it low, that means we are going to turn it off. So once we do that, and then we upload the new code. You see, I did not go to verify. I just click upload. It will compile, and if there's an error, then we'll get it there. So, all right, we're good. So now this guy is blinking clearly, and this internal LED has been turned off. Okay, the internal LED has been turned off because this is what we just need for now. If you move this guy's in pin 12, if you remove it from pin 12 to other pin 11, nothing is going to happen. Any other pin, nothing is going to happen. Any other digital pin, nothing is going to happen, because the digital pin we have in our program is what? Pin 12. Now if we change the one in our program to pin 11, let me do that now, to pin 11, and then we'll upload this code to the Arduino. What's going to happen? We have changed it in our program now to pin 11, and we are uploading it to the system now. Now it's no longer working unless we move this in from pin 11 to it's no longer working unless we move this from pin 12 to what? Pin 11. Now it's going to work. Good. Now remember I said something, that if we put this pin in the 5 volts, which is the live of the Arduino, it's going to just turn on. That one in our program, there is no where we address or we talk to the pin of the 5 volts, because that pin actually just supplies power so we are not actually controlling it, it's just powered. So for we to control it, we need to use either the digital pin or the analog pin. Analog pin is actually just input, then this guy can be input or output. So the pin where we address, where we talk to in our program, that's the pin you connect the live of the load, which is the LED in this case, to. Of course I connected it through a resistor, and then back to ground. Okay, so I think we've said enough and a lot in this video. So if you have questions, of course, put them in the comment section. Like, share, subscribe, and I'll see you in the next video. Thanks a lot for watching, and bye for now.